All right, this is Note-Taking Guide 5.2. We're going to talk about a function today called a piecewise function. And just like I was showing you guys on the bell work, it's really just graphing functions that we already know how to graph and keeping a piece of it because of a domain restriction. So what we're going to do is we're going to write the equation of the first piece of this graph right here. So looking at this graph, what kind of a graph is this? Is it going to have a squared in it, a cubed in it, a square root, an absolute value? You guys know what it's going to look like. What does this equation look like? It's going to be something squared like that, right? Because it's a parabola. So what I need to know is I need to know how far left and right and how far up and down I went from 0. So here's my 0 right here. How far to the left did I go? I went -5, right? So -5 shows up inside the parentheses as +5. Do you guys agree with me that that +5 tells me to go left 5? Yeah. Okay, how do I get it to tell me to go down 2? It would be a -2 back behind, right? So -2 back behind tells me to go down 2. So left 5, down 2. Then I need to check my pattern to make sure I didn't have a pattern change. Do you guys remember the original pattern on a parabola? I'm going to zoom in so we can see this closer. The original pattern is from the vertex point over 1, up 1, over 1, up 3, over 1, up 5. It followed that pattern, so I don't have a number out in front right here. So my equation would just be y equals or f of x equals that equation right there. So are you following me on how I did that? We're doing okay? All right, I want to write the equation of the second line now. And I said line because I can see that it is a line. So I know that the equation of a line is in the form y equals mx plus b. Does anybody remember where the b value comes from? It's where your graph crosses the y-axis, right? So where is it crossing the y-axis at? 5. Good. My b value is 5. The only other thing I need in order to do an equation of a line is I need to know what the slope is, so that can go in front for my m value. So I always have to run to the right. So if I'm right here at 5 and I have to run to the right, I went down 1, right 1. So my slope would be a -1. Because I had to go down 1, right 1 to get to my next point. So I have a parabola, I have a line, and actually only pieces of them, and now I need to graph or write the equation for my third piece. Anybody remember what this graph looks like, its equation looks like? Is it going to be a square root? Yeah, so how far left and right did I go? How far up and down did I go? Left and right is under here, underneath the grouping symbol. So to go right 1, I would have to show -1. And to go up 5, I would have to go +5. I would then need to check my pattern to make sure that it was the right pattern. Did I go up 1, over 1, up 1, over 3, up 1, over 5? I did, so there is not a pattern change. Again, I can do f of x or I could do y equals here. So what I did here was I took my graphs and I wrote the equations from them. So then it goes on to ask me questions about the domains of those graphs or the x values of those graphs. So on this first graph right here, what part or what do you notice about the x values, or what pieces of the x-axis does my graph cover? Do you see how it starts here at -7 and it goes until it gets to -2? You guys following me on that? So could I say that my x values are greater than or equal to -7? I can say equal to because of the solid dot. And my x values are less than or equal to -2. Do you guys agree with me that I could write that inequality to describe my x values? If you wanted to just say it the opposite, like write it as 2 separate, you could have written it out as 2 separate ones also. But anytime you're sandwiched in between, we would sandwich that x in between also. So you could have written it either of those ways. All right, if you look at the graph of the second one, what x values does it go to? It starts at -2 and it goes to +1. So how would you write me an inequality for that? You could say that x is greater than or equal to -2 and less than 1. I don't get to put the equal to there this time because up here on the graph you can see it's not equal to at the 1. It has that open circle on the line. Okay. And then if we're going to look at the y values of the third graph, where does it start at? It starts at 1 and it goes to infinity. So I can go x is greater than and equal to 1. Again, why do I get to put the equal to sign? I get to put it because of the solid dot at the end of the graph. Are you guys noticing how I did those domain restrictions? So domain restrictions are determining what piece of the graph that we keep. So this is now, we're going to take all this information that we just found in this first section here, and we're going to translate it over here into what it would look like in function notation. So when we do a piecewise function, we're going to tell the equation of the graph, and we're going to tell what piece of the graph to keep. So I'm going to just come and copy those equations from the first box that we just did over into these lines over here, because we're really just writing those same equations that we figured out were the equations of our graph, and then we're going to do our restrictions for it. So the graph will be x plus 5 squared minus 2 for all of my x values that fit these descriptions. And we already wrote our x value descriptions over on the other side, so I'm really just copying them into place also. So the second one had domain restrictions that went from -2 to 1, and the last one had domain restrictions that were greater than or equal to 1. So this is how you'll see a piecewise function look. It will tell you to graph this graph and keep it for these pieces. Graph this graph, keep it for these pieces. Graph this graph and keep it for these pieces. So what this fancy equation tells us is that there are 3 parts to our function, and what parts we're going to keep because they're the valid parts to keep for our function. Okay? Now there's 2 ways that we can evaluate these kinds of graphs, these kinds of equations. We can evaluate them by using the graph, or we can evaluate them by using the equation. I want to show you a couple of them about how they work so we can see. So this says evaluate f of -4 using the graph. -4 is my x value. I want to know what my y value is when my x value is -4. So if we come back over here to the graph, and I'm going to zoom in so we can look at it really close, and we look at where our x value is -4. Do you see where our x value is -4 right here? This is x is -4. What's the y value on my graph? -1. So my answer that I'm going to put over here is -1. Now I want to show you how to evaluate that using the equations up here so that we can show you algebraically how to do it also. So it says that my x value is -4. Okay, so this is my x value. I first will go up here and find which of the equations I can use. So my x value is -4. So is -4 in between -7 and -2? Or is -4 in between -2 and 1? Or is -4 greater than 1? Do you see how I use these restrictions to decide which equation to use? -4 fits into the top restrictions, which means I'm going to substitute it into the top equation. Does that make sense? So I'm going to substitute that in. I'm going to write it down here. I'm going to go -4 plus 5 squared minus 2. And I'm going to evaluate that to see what my answer is. It's what? It is -1. So my answer comes out to be -1, which is the same answer that I got when I used the graph. So you can evaluate them by looking at the graph, or you can evaluate them by using the algebra. Now, I don't think we need to take the time to do all of these, but let's do a couple more to make sure. So let's go with f of 0. So using the graph, come over and look at the graph. When your x value is 0, what's your y value? 5. So f of 0 is 5. Now let's check it out algebraically to make sure it works out the same way. Let's come and decide where 0 is going to go in at. Is 0 between -7 and -2? No. Is 0 between -2 and 1? Yeah, so I'm going to substitute it into this equation this time. So it would be a -1 times 0 plus 5. And guess what? I get the same answer I did when I looked at the graph. Does that make sense to everybody, how we're using the graph or the equations to figure out our value?
Is that a 1x?
It is a -1x, yeah. Yes.
Is it always going to be the same with the equation and the graph?
Yeah, so the equation and the graph should always match up. So if you're evaluating the same number on the graph as you are in the equation, you should always get the same solution. Does that make sense? Okay, I want to try one more with you because I think that this one could be a little bit confusing. So let's try f of 1. So come over here and look at the graph with me on f of 1 and tell me what you think. So this is your x value of 1. Look, I have two parts of the graph here to look at, but I want to know where it's equal to when x is 1. So which value is it equal to? It's equal to 5 because it's colored in there, right? Doesn't the open circle mean not equal to? And the closed circle means equal to. So my answer there should be 5 for f of 1. Now I want to show you what that's going to look like when you're trying to decide which equation to use. Because if we're going to put 1 into our restrictions, we have to decide here, well, is 1 between -7 and -2? It's not. We know we're not using this one. Is 1 between -2 and 1? Or is 1 greater than 1? Do you guys see how that both of them look like they could possibly happen? But here's the reason that this one doesn't work. If I need to substitute 1 in, it would have to be equal to 1. Is this one equal to 1? No, but is this one equal to 1? So I could substitute the 1 into this equation, but I cannot substitute the 1 into this equation. I could do like anything very, very close to 1, but not the actual number 1. Yeah.
So the question, you can't have two answers then?
Well, in theory you can't. If these are functions, when you substitute in one x value, you're going to get exactly one y value, because it wouldn't be a function otherwise, right? So, all right. So guess what I'm going to get when I substitute this 1 in? Do you have any idea?
Let's see, 5.
Yeah. But do you see how it worked algebraically when I put it into the right equation? That will be 0, 0 plus 5 is 5.
And you have
Okay.
Y's, but not as many Y's as you want, but not extra X's, right? Like, Y is happening again. Oh no.
So Collins asked him the question about x's and y's, and I want to bring up these are piecewise functions, which means they have to pass the vertical line test, which means you're right. The x's can't repeat because you can't have more than one x value with the same, right? You can't have an ordered pair here and you can't have an ordered pair here. So the x values can't repeat, but it's okay for the y values to repeat. So look right here. Do you see how y equals 5 right here? And y equals 5 right here? And y equals 5? Like the y's are okay to repeat. Did that answer your question?
Function, it could be like weird, like you're thinking.
Yeah, these are all functions that we're dealing with though, so they have to follow those rules. All right, we're going to write the equations again for this other piecewise function right here. So this first one is a parabola. I know it's going to be squared, and I need to find the vertex point. It starts right here, which means I went left 4, so I'm x plus 4, and I went up 3, which means I'm plus 3. Does everybody agree with me on that equation? Check your pattern real fast to make sure it didn't change. Over 1 up 1, over 1 up 3, so I'm good. But then I have to state my restrictions. So my x's, they go forever in the negative direction, but they stop at -3.
The negative 3 is not equal to the open dot.
Yeah, and it's not equal to at -3 because of the open circle count. So could I just say my x's are less than -3? Does that fit the restrictions okay? All right, this next line, anybody know what this line is called? It's going to be y equals 2. Good. And I'm going to keep that in between two numbers. I'm going to keep it in between -3 and in between 1. So it's got to be greater than or equal to -3 because of the solid dot, but it's going to be just less than 1 because of the open dot. You following me on that? Go ahead.
So there couldn't be two open dots, right? Because you have to have the x's connected in some way.
Well, they don't actually have to be connected in some way. You could have a gap between these two and it would be all right. You can have empty x values. That would be okay. Thanks for asking that. All right, this next one is a line. You guys, it's hard to tell where this line is actually going to go unless you kind of extend it. I like to extend it so I can see where it's going to cross the x-axis at, or I'm sorry, the y-axis at, because I need that y-intercept. Because remember how we're y equals mx plus b form and we need to know where it crosses? So I know it crosses at 5, and then I just have to put my slope on. I go down 2 and right 1, so that slope would be a -2 out in front. Now, because I extended that, I have to be really careful with where I'm doing my restrictions, right? Because I extended that out on my own. My restrictions actually started at 1 and went everything to the right of that. So my restrictions are x is greater than or equal to 1 because it was a solid dot right here at 1. Okay. Now let's take a minute and evaluate these expressions where it asks us to. So when f of x is -5, so my x value is -5. What's my y value equal to? It's equal to 4. Now I could have substituted in here and I could have figured it out. -5 would have to go into this equation right here. So -5 plus 4 would be a -1. -1 squared is +1. +1 plus 3 is 4. Okay. So how about f of -1? 2.
Because it just
Yeah, for that it will always be 2.
Because there's no x.
Yep.
So
And so let's look at what that looks like algebraically. So -1 fits into this category right here. And is there a place for me to substitute an x in? There's not. It's just the number 2. So your answer will always be number 2 if you're in this category right here. And then this last part right here, f of 5. So 5's over here. Can you see where it would be better to substitute it in this time instead of try to figure out on the graph? So let's figure out where it's going in. It's going into this equation right here because 5 is greater than or equal to 1. So I'm going to go -2 times 5 plus 5.
it's -5.
It is -5. So does it make sense that we're down here somewhere or close to down there somewhere when we're over at 5? So my answer on this one would be -5. Questions on how I did that? No? All right, so now we want to go the opposite direction and we want to graph some of these instead. So this is actually 3 different graphs with 3 different sets of restrictions that we're going to graph here. So let's start with this first one. It's a line, 1/3 x minus 1. So where do I start out at? Yeah, down 1. And how do I follow my slope?
Up 1 over 3.
Up 1 over 3. My line goes through those ordered pairs. Now, you guys, I want you to think about it because if you graph this whole line right now, then you're going to have to scribble out or erase, right? We don't really want to scribble out or erase. And I want to grab a pencil so that I can erase for you because I want you to see what the restrictions are going to be. But I'm just going to graph this whole thing for now, but you guys watch what I'm going to do because my whole line is not my answer. So here's my line, but I'm only going to keep it where my x's are less than -3. Well, my x's are -3 right here, so I really clearly need to extend that line further, right? Because I'm not doing a good representation of what that line looks like. I keep it where my x's are less than -3, so at -3 is going to be an open circle. I keep it in the direction where my x's get smaller, and all this other part doesn't matter because it doesn't fit my restrictions. Does that make sense to everybody? Why I only kept that part of my graph? Okay, let's do the next one. This is y equals 4. So it would be this line that goes through right here. But I don't keep the whole thing. I only keep it between -3 and +1. At -3, it gets to be equal to it. At +1, it gets to be not equal to it. And I'm keeping everything in between there. All the other part doesn't fit my restrictions. So I'm not going to keep it in my answer. Then I have one more graph to graph on here. So I have the square root of x minus 1 plus 1. So right 1, up 1 on my graph. It's a square root, so it follows the pattern up 1 over 1, up 1 over 3, up 1 over 5. And it would come through just like this. And I'm going to keep this graph where my x's are greater than or equal to 1. So I actually get to keep this whole graph. And that would be my solution right there.
At that point, is there any need for like the dot?
Like solid or dotted?
Yeah.
Well, I know I'm all solid this time because that's equal to that.
Oh yeah, but like I mean for the end, is there any need to put a dot there?
Oh, do you mean right here?
Yeah.
Well, you do know it's equal to that because that was its vertex point, so we would probably want to be a solid dot there. Okay. All right, next one. How you feeling about it? Not good? Bad? Okay. This is a cube root graph that goes down 2. On the cube root graph, I'm normally following that pattern over 1, up 1, and then up 1 over 7. So I would be coming through like this. But I don't keep that whole graph. I only... What?
Why do you think you got one?
Oh, because I did it, because I said 2 and I did 1, huh? Thank you for correcting me on that, Colin. Colin's right. It says down 2, and I started down 1. Sorry about that, you guys. So my graph would come through like this normally, but I'm only going to keep it where my x's are less than or equal to 1. So here they are 1 right here. So I'm going to keep it this direction, and the rest of it is going to be gone. Then I'm going to do my other graph. I'm doing the line -2x plus 5. So I start up at 5. And I go down 2 and over 1. My line goes through those ordered pairs, but I only keep that line between 1 and 5. At 1, it's an open circle because it's not equal to. At 5, it's a closed circle. And I keep everything in between there, but the rest of it I don't need because it's not part of my restrictions, and I'm done. Okay, questions on how I did that? All right, I am not going to work these last 2 problems with you today because they're super challenge bonus problems. We could totally do them. They're not that hard. We'll do them for bell work in the next couple of days. But that's the gist of how you graph a piecewise function.